like, no, it's really not. Solve the equation, the exact solution is over the interval 0 is less than or equal to x, which is less than or equal, whoops. We don't put equal on the 2 pi because 0 and 2 pi are exactly the same. So we're not going to list that answer twice. All right, so Sarah.
Yep.
Did you try something?
Well, I did try whole 2x. I tried a few things.
All right.
And I guess maybe I gave up too soon, but
Yeah, maybe. Well, it depends on what you did. We want to do a substitution with our formulas. The only thing is that we don't want to get all the way down to just sine x. Because that equation, you probably got there, is probably ugly. Okay, but what we can do is say to ourselves, this can be thought of as, instead of sine 4x, is the sine of 2 times 2x. So now this is like my theta. So we have the sine of 2 theta is 2 sine theta cosine theta. So if we actually work that, okay, the problem being right here is we have the sine of 4x and the sine of 2x. We have two different arguments in the same equation. And it's not, they're not squared, they're not, we want to try to get the same type of angle. It's okay if we're in terms of 2x. So that's actually what we're going to do. Okay, let me get rid of that theta. So the sine of 2 times an angle is 2 sine of the angle cosine of the angle. If you do that and then stop with the substitution, let's just solve this equation in terms of 2x being my angle. Okay, so I have this set equal to 0. When you have an equation set equal to 0, your next step is probably going to be to
Factor out.
Factor what they have in common. They have a sine 2x in common. So let's factor out our sine 2x. So if I pull my sine 2x out, I've got 2 cosine 2x. And if I pull my sine 2x out, what am I left with?
1.
1. All right, I have it factored. When you have an equation that's set equal to 0 and it's factored, now what are you going to do?
substitute terms equal.
Set them both equal to 0. So now we're going to say sine 2x equals 0, and we're going to say 2 cosine 2x minus 1 equals 0. Okay, so our whole thing here in this whole process in this transition was get the same argument of the trig function. That was the whole problem. Sine of 4x, sine of 2x, can't have it. You're wishing it was sine to the 4th power, sine squared, but it's not. All right. Good. I like to substitute at this point, so we can say, let's let this be A. So now I'm solving the sine of A is equal to 0. Okay. Hopefully, you've done enough equation solving that you are comfortable that the sine is going to be 0, 1, or -1 on your quadrantal angles. Okay, so we can do this a few different ways. We can do y over r, so it's 0 over 1. Where is y 0? On the x-axis. Okay. What angles represent the x-axis when we think in terms of rotation. 0 and
Pi.
pi. So a equals 0 and pi. We want to be super specific. Our A angle is 0. Okay? However, we got a problem. We're trying to solve for x, not A. If we solve for x and we divide by 2, my x angle are all my A's divided by 2. So if these are, let me erase this because it's a little close. If that's A, I want x, so that means I got to cut everything in half. 0 divided by 2,
0.
0. Pi over 2 divided by 2, pi over 2. All right, now, the only problem is we found angles, we divided by 2, but we're supposed to solve. I know my smudge mark is looking a little awful. We're supposed to solve that equation all the way to 2 pi. Right now we're at pi over 2. Are there more angles? Maybe. If we think about the graph, okay, we know that our period is pi, and when we solve to 2 pi, it's actually going to be 2 cycles of the sine curve. So we're going to do that, and so here, when we're trying to find when sine equals 0. So we found 0, we found pi over 2. But there's a whole nother cycle of sine by the indicated domain of the question that we need to figure out this other angle here and this one here. Okay, so when you find, now you could, there's 2 ways to do it. The books method is going to take this and say, okay, I need to do my 2k pi. Actually, this one's not so bad because my rotation, we can do this all at one. So my rotation is here, 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 here. So it's all just kind of multiples of pi. So we can kind of take a little shortcut with the 2k pi, just add pi all the time. Okay. If you set up your equation, the generic all solutions, you can do it like that and just plug in integers for k. If you're like, I'm just going to kind of think about it. So we've got, here, let me erase all this blue. So we've got 0, we've got pi. Another solution is 2 pi. Another solution to that is, put me over here at 3 pi. Okay, and if we think about it, if I took 0 and added a revolution, which in radians is 2 pi, I get 2 pi. If I take pi and add a revolution, I get 3 pi. I could continue and just add 2 pi and get 4 pi. Add 2 pi, get 5 pi. Okay, so we're just adding a unit of rotation, 360 degrees or 2 pi because we're dealing with radians. All right, so these are, and you do that to your A angles. Okay, so now we got to take all these and we got to cut them in half. So we're up to this one. 2 pi divided by 2, I get pi. 3 pi divided by 2, I can't do squat 2, so it's just 3 pi over 2. 4 pi divided by 2 is 2 pi. Are we supposed to list 2 pi?
No.
No. 5 pi over 2 is 2.5 pi, which is too big. So these are too big. We didn't have to go that far. Okay, but if we were solving for further, we would. Now, notice, and this is going to be kind of helpful here, and also helpful when we do a little bit of chapter 5. So we added 2 pi and then divided by 2. Added 2 pi divided by 2. Added 2 pi divided by 2. We might want to notice something that happens, because we're always adding 2 pi and then dividing by 2. What's 2 pi divided by 2? okay? We want to take corresponding angles. So we started with this angle and this angle. Okay, 0, if I add pi, guess where I get pi? If I take my other angle that we got from our original picture and I add pi, I'm at 3 pi over 2. If I took this, it's not the same, but if they're related, the star angle, and if I added pi, I would be at 2 pi. And then if I take the smiley face angle, they're related. If I added pi to it, I get 5 pi over 2. So we can get the additional angles that way as well. So you can either think about the picture or we can do it. This one's going to be a little bit easier to kind of get this understanding. This one's a little weird because it's quadrilateral, but now this is all for just the sign of 2x equals 0. We still need to do the exact same thing for this. Cosine of 2x, if I bring that 1 to the other side, it's positive. We have to divide by 2. We're dividing by the coefficient. Here, hold on, let's just do it. We have to divide by this 2. We cannot divide by that 2. That doesn't do anything. Okay, so that 2, you can't move it out, you can't pull it out, you can't divide by it. We're not going to do that. When we divide by 2, that coefficient cancels. And we're going to leave our equation, the cosine of 2x equals 1/2. Okay, I can't pull that 2x out. The only thing, if you really wanted to do, you could do a substitution for your cosine 2x formulas. In which case, I would probably not choose cosine squared minus sine squared, get one true function. So you could do that. Honestly, once we're used to this process, it's not so bad. Okay, so we do our substitution. Let's do it in black. So call that b. 2x equals b. So the cosine of b is 1/2. Okay, so it's not 0, 1, or -1. We're not on an axis angle. We're going to be in the quadrant. We have an x, we have an r. We're going to draw triangles. And we're going to draw in what quadrants? What do I have to think about? What are we thinking about to figure out our quadrants? It's positive. So we're drawing it in the first and the fourth. Cosine is x over r. So we're going to do 1, we're going to do 2. We're going to do 2. What's the third side?
Square root of 3.
Square root of 3. I care about this angle, the reference angle, making the connection with the origin. So what angle is opposite of root 3?
60.
60. Are we answering in degrees or are we answering in radians? Let's go radians. Let's think in radians. 60 in terms of radians is?
Pi over 3.
Pi over 3. This reference angle here is also 60, which means the reference angle is going to be pi over 3. But we are now in the fourth quadrant. And if we say to ourselves 2 pi, but I'm really supposed to be thinking in terms of thirds, if I get a common denominator, or however you want to think about it, 2 pi is 6 pi over 3, so let's just think thirds. Our rotation is starting at 0, rotating all the way around. We're stopping short of 6 pi over 3 by 1 unit of pi over 3, which makes this angle
5
pi over 3. So, my B angles, which is the picture, let's go back to black. B is pi over 3 and also 5 pi over 3. So we can get additional revolutions of the picture. Okay, so now once we need more angles, we can do it 2 different ways. We can just focus on the picture and say, well, I could go, let's go green, I could go all the way around and then stop there. Another answer is 6 pi over 3 plus pi over 3, or 7 pi over 3. Where am I? Oh, black. Which, if we think about we added 2 pi, which is the same thing as 6 pi over 3. Okay, we could do the same thing to 5 pi. Add 6 pi over 3. And I get 11 pi over 3. How do I know when to stop? We could go one more. Generally, if it's 2, you do 2. But if we added 2 pi, which is 6 pi over 3, we stopped here, and that would be 13. Okay, so these are all my B angles, all those picture angles. We need to get to X. Let's go blue. 2x is equal to b, so that means if I divide by 2, I don't want to take those fractions and divide it by 2. I'd rather think of multiply by a half. Okay, so rather than dividing by 2, I'm going to multiply by a half. So my x angles are take my b angles and multiply by half. If I multiply this by 1 over 2, I get pi over 6. If I multiply this by 1 over 2, I get 5 pi over 6. If I multiply this by 1 over 2, I get 7 pi over 6. Am I good? Am I still less than 2 pi?
Yes.
12 pi over 6? Totally good. I can multiply this by a half, so I get 11 pi over 6. We're getting pretty close to 2 pi. And sure enough, if I multiply this by 1/2, I get 13 pi over 6, which is too big. This right here is greater than 2 pi, which is 12 pi over 6. So we chop it off. So you have 4 wonderful answers, 4 wonderful answers for a total of 8 wonderful answers. Okay. That was 73. 4751, I can, all right, so how are you guys feeling about your equations?
Yeah,
Okay.
less than
So,
positive.
I'm okay, you guys have to turn in 3.5, that should be done. But if you want to turn out, if you're finished with 3.6, and I'm so sorry if you stayed up till like 2 o'clock in the morning to finish 3.6 to get it done and in today. But if you probably need, if you want more time on 3.6, you want to turn that assignment in on Friday, I will take it Friday, it will not be late. If you're ready to turn it in today, turn it in, get rid of it, okay? 4751, we need to move on. I will get that typed up and send it out on an email.
Have you posted any videos about this on the Canvas at all?
So, there are videos for 3.5, because I checked. The equations, probably not. But if you want some videos, just there might be, don't know, you have to check. Or you check, and if there's not, ask for them, and I will send them. All right. Chapter 4. We are going to be working with what we call oblique triangles, which means they're not right triangles. Okay, so, you know, we could have, this is 60, and this is 42, and this side is 8, and the question is solve, find all the remaining angles, find all remaining sides. Alright, I'm going to kind of backtrack a little bit. We're going to actually write this out, how the textbook is going to. So, normally angles are measured and labeled with capital letters. We can, you know, be creative and spell cat. Should we spell cat, or should we just do ABC?
Cat.
Okay, so if we have triangle okay? That is telling you that your angle vertices can be labeled in the capital letters. Now, the sides are labeled appropriately with respect to the angle it's opposite. So this angle is 60, so they might have told you that angle C is 60 degrees. The side opposite angle C is indicated by a lowercase letter. So they tell you that lowercase c is equal to 8. You know that that is the side opposite angle C. Okay, and then they also kind of said that angle A is 42 degrees. All right, so we need to figure out angle T. We need to figure out side A. And we need to figure out side T. Which one's the easiest to find?
Capital T.
Angle T. How are we going to find angle T?
Add together to 180.
All the angles in a triangle have to add up to 180, so we can add this up and we get 102. And that means we take 180 minus 102, and you end up with 78 degrees. Yay! All right. Based on the time that we have, I'm not going to derive the formula. It is in your book, and you can be able to look at the derivation if you're super interested in it. The law of sines is a relationship that exists for any triangle. Okay? Use on any triangle. And it says that the sine of angle A over side A, that fraction ratio is equal to the sine of angle B over side B, which is also equal to the sine of angle C over side C. Or, with cat, the sine of C over C is equal to the sine of A over A, which is equal to the sine of T over T. Okay? You also may have, if you've done this in high school, another comparable relationship is A over the sine of A, which equals B over the sine of B. I usually don't use this one, but if you can think ahead super well, you can figure out which one's going to be best when. I just use the top one. Okay. We are not solving three-sided equations. So we are going to use just two pieces. We're not going to set it all up and try to solve it all together. That's a nightmare, okay? Notice, if we're going to set up an equation, oh, wait a minute, hold on, we know 78. Or actually, let's not even plug in 78. Let's just look at this. Okay, so if I'm going to solve something, and I'm going to take one of these and have another part, and just kind of focus on, you know, two fractions equal to each other, I need three pieces of information. And basically, I better have an angle and its opposite side. Okay, so if you ever have an angle and its opposite side, that is super exciting. Because we can use the law of sines, which is a lot easier than the law of cosines, which we're going to do on Friday. Okay? This formula is not hard. You can memorize that formula. I will not give you this formula on the test. It's easy. Okay? And you're going to do it so much that you're going to know it. Okay? So, we're going to focus on an angle and its opposite side. Okay, when we get, that's going to be the key to use the law of sines when we get this all conglomerated together with the next section. So, with respect to that triangle over there, we know that angle C is 60, and we know that its opposite side is 8. So, we're going to set that up. We got the sine of 60 over 8. We didn't quite figure actually work with and figure out a piece of information with angle A. Angle A is 42. What can we figure out based on angle A and this other information that we've got? Side A. So we can say that the sine of A, or the sine of 42, is over side A. Those three pieces of information. All right, so now we're going to solve this. We've got that set up, and we're going to solve. Okay, this is the only time I think the vocabulary term cross multiply is applicable. I know people use it when they're getting common denominators and it makes me cranky, but, okay, if you have a fraction equal to a fraction, you can take the cross products and set them equal to each other, okay? Or you can just multiply both sides by 8a, which is the common denominator, and you're going to get the same thing. Okay, so cross multiply, get 8 times the sine of 42 is equal to a times the sine of 60. So whether you cross multiply or you multiply both sides by the common denominator and you cancel. All right, I'm still trying to solve for a. So what are we going to get when we solve for a? How do I get rid of sine 60?
Divide by sine
We're going to
60.
divide by the sine of 60. So a is 8 times the sine of 42 divided by the sine of 60. Okay, you're going to have your calculator. Now, your final exam. You're going to have your calculator on your test. You're going to punch this up. Your final exam, I haven't quite decided. Sometimes I let you use your calculator, sometimes I don't. I'm probably not going to. But on the final exam, that would be your final answer. And the directions are going to say, you know, express your answer in terms of trig functions or, you know, inverse trig functions or whatever. That's side A. We don't really have a concept of it because we couldn't punch it up. But you are going to have a calculator, scientific calculator. This is the reason why you want to have your calculator that you're going to be using on the test, because first of all, if you were working in radians on one particular homework problem from 3.5, we're going to make sure our calculator is back in degrees. Okay, quit. We're going to punch this up. So you're going to hit 8 times. You're going to hit your sine key. Does anybody have hit their, let me know if you have a reverse trig function calculator. You hit your sine key, it's going to have sine, and it's going to put a parenthesis. You're going to hit 42, and guess what you have to do? Close your parenthesis. Okay? We're going to hit divided by, and we're going to hit sine. Guess I can do that in black. And the calculator is automatically going to have an open parenthesis. You're going to hit 60. Honestly, you could hit equals. You could close the parenthesis. Usually that back parenthesis doesn't really freak it out. But it's always, you know what, I just say it's always a good idea to get in the habit because we're going to be using your parentheses a lot. You are going to need to make sure you get your answers that the back of the book have. We are going to be using our calculators on this test. Times sine of 42 divided by the sine of 60. All right, so we get A equals 6.181163771. All right, back in chapter 2, there was a handy-dandy chart on page 140. And it told us our rounding conventions. So, if you have your angle versus your side length. If your angle is to the nearest degree, which is what we've got. We've got 60, we've got 42. Our side lengths are going to be 2 significant digits. If your angle is to the nearest 10th, then you're going to give your answer, your side lengths, to 3 significant digits. If you need a review on significant digits, go to assignments, go to homework, go to chapter, probably test 2, test 1, since this was the first time it was introduced. Test 1, in there, you're going to have a link to significant digit video. It's a Khan Academy video, so if you need help with that. So here we're supposed to give our side length to 2 significant digits. So right here, 6.1, except the 8 is going to make us do
2.
6.2. Okay, the only the only problem is we don't actually have to use side A in the rest of the problem, so that's good. If you're using and you needed to use side A, it's going to be better to use this rather than your rounded answers. It's not so hot to round in the middle of a problem. Okay, so over here, we also, so side A is 6.2. Okay, side T, we need our 78. And can we visualize how we can set up a very similar equation? And it's going to be better to go back to the specific information they gave us rather than the answer we just rounded. So don't use angle A and side A because we just rounded side A. Go back to angle C and side C, this right here, to figure out, oh, maybe I shouldn't have circled this green thing. We're gonna, not that. We're gonna go back to this to figure out angle T. So we can say the sine of 60 over 8, so the angle on its opposite side. We want to find side T, so we're going to now use 78, so we say the sine of 78 over T, and we do the exact same manipulation of the equation to figure out side T. Yes? Easy? Fabulous. All right. We have an ambiguous case. Okay. All right, so we've got triangle ABC. We've got, they actually don't use the angle sign, they just say capital B is 32 degrees. We've got side A is 42 degree, or 42 length, and B is 30. And they want you to find angle A. Find capital A. Okay. You can draw yourself a picture. I think it's always fabulous. You might want to just plug and chug into the formula. It doesn't matter. ABC. Angle A, we don't know. Angle B is 32. Side B is 30. Side A is 42. Okay. Again, lost sign is going to be an appropriate thing to use because we have both pieces of information for an angle and its opposite side. If you have that going on, you are super smiling. Because the law of sines is a lot easier to do than the law of cosines. So we're just gonna set up the sine of 32 over 30. We're gonna use 42, which is a side length. What's gonna go in the numerator? Sine of A, right? It's opposite angle. Okay, so this side, we could cross multiply, but notice we're trying to solve for this, which means we just need to get rid of 42. So if we just make it easy on ourselves and say, let's just multiply both sides by 42. Then we get the sine of A, if you don't mind me flip-flopping the sides. 42, the sine of 32 degrees divided by 30. You can cancel and simplify the 42 and the 30. We're going to punch it up anyway. All right, this is where we've got to be careful. Why do we have the ambiguous case? Okay, let's punch up 42 times the sine of 30. Close your parenthesis, divide it by 30. 0.7. Wow. That's weird. All right. Anything else got?
You did sine 30 and sine 32. It's still 0.7.
Oh, that's why. That is totally weird. Okay. Times the sine of 32 divided by 30. All right, 0.74. Do not round this decimal. Okay, 4,188. Okay. How do I figure out A? I've got the ratio as a decimal. I want the angle.
The inverse sine.
We're going to do the inverse sine. This is where you're going to want to make use of your A, N, S key, answer key. So like as soon as you hit the inverse sine key, you're kind of like starting a new row of your calculator computation. I want that decimal and I don't want to write it down and I don't want to chop it off. So if I do the inverse sine of the answer that you just had, you're totally awesome, right? So we do inverse sine of the answer, and we get 47.892. So A equals 47.892. Now, oh, that's an answer key. Tell me about the sine ratio being positive. Quadrant 1 or quadrant 2? Can quadrant 2 angles be in a triangle? Possibly. Okay, so this is the reason why we're going to get an ambiguous case, because it's not going to create necessarily a specific triangle, and sometimes it doesn't even create a triangle at all. Okay, do you guys remember your congruence theorems from geometry? Side, angle, side, angle, side, side, side. Do they still teach that in high school geometry? Do you remember the one you couldn't use? Okay, guess what we've got? We've got an angle, a side, and a side. Okay, so this right here, the ambiguous case in the law of sines occurs when we have two sides and an unincluded angle. Okay, the included angle between these two sides would be this right here. Okay, so angle C would be the included angle between those two sides. Angle A or angle B are considered unincluded angles. Okay. Now, how are we going to figure out what's going on? It's not that bad. So, and the answer is 47 degrees, 47.9. Okay, although I suppose we're supposed to do two significant digits, so, or I mean, yeah, to nearest degree, so 48. Well, guess what? This reference angle is 48, and what we need to ask ourselves is, is this angle possible for, where are we doing side angle A? Right here. This is 32. So this triangle right here, totally fine. We got 32, we got 48. We have room for our third angle. We can add up, subtract from 180 and still get a triangle. All right, so if I'm going to try to figure out what this second quadrant angle is, we take 180 and subtract 48, right? We get 132? Is that correct, 132?
Yes.
132. So our question is it possible to have a triangle that has a 32-degree angle, a 132-degree angle, and still have room for the third angle? Totally. These adds up, it adds up to 164, which means we have what? 14? 16? And you subtract from 200.
Yep.
Okay? We actually get two different triangles. Okay? So I'm going to encourage you, we can talk about this on Friday, but if you like a visual, this is an algebraic way or mathematical way of why are we getting two triangles. If you wanted to kind of look at the top of page 295 to figure out a visual with respect to what's happening, why are we getting two triangles? Otherwise, we'll look at it on Friday. So we can get two possible triangles. Guess what? You get to solve both of them. You're so excited, I know. Okay. We might, so now suppose, when could we, so we could actually get 1, 2, or 0 triangles. Okay. Here we got 2. When could we possibly get 1? Suppose we did all this. So we have 32 here, and you do all this stuff, and you're solving for angle A, and you end up with angle A is 70 degrees. Totally is fine. But you're like, well, wait a minute, hold the phone. 70 is here, which means there is a 70-degree reference angle, which means that this is 110. Oh, there. 62. No. Do all the math. 70, totally fine. 70 over here is 110. Can I have an original triangle that had an 82-degree angle and now this 110-degree angle? Okay, 82, 110, busted. So it's not working, I throw that out, I don't solve that one. Okay, when could I possibly get no triangles? We're going to do all our equation. You set up your equation. You're going to do all your math. You're going to get the sine of A equals 1.46, blah, 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 blah. Tell me about the sine ratio.
Has to be between 1 and -1.
It's got to be between 1 and -1. Okay, or for triangles, it's got to be between 0 and 1. Okay, y over r is not happening. Sine ratio cannot be bigger than 1. So this has no solution. So actually create no triangle. All right, we are out of time. However, we're going to spend 60 seconds if you have. Some of your word problems are going to have navigation in there. You're going to have excuse me, north 23 degrees west. I like to say 23 degrees west of north, but other people just say north 23 degrees west. Okay, you are always going to have north or south up front, and we are always going to draw with respect to north or south. So I'm going to draw this angle. So from the north, we are going to rotate 23 degrees toward the west. Okay, north, south, I think you got that. If you mix up west and east, it spells we. Okay, we're gonna rotate 23 degrees. Never have we rotated from the positive y-axis or the negative y-axis, but now we are because we're in a different paradigm where we're doing navigation. Okay, so that angle, you know, maybe you see a bird in that direction. Okay, the other thing that is going to happen with navigation is that they're going to, let's see, and this is called bearing. This is bearing.
Use that in surveying.
Huh?
Use that in surveying.
Oh, you did?
You do.
Oh, excellent. Heading. You know, think of, you know, Pirates of the Caribbean. Okay. Heading is just going to be an angle measure. Okay, so that's the kind of the difference. This is the way you're sailing, that's where the way you see something. Okay. This is always with respect to north, rotate clockwise. We don't have negative headings. Okay, so we're not going to have negative headings. So we're always starting here. We're changing our paradigm. If I'm going to draw a 216-degree heading, I am not starting on the positive x-axis. I'm starting from north. And we're going to rotate 90, 180, 216 degrees is going to be some way that direction. You know, if this is, you know, or where I don't even know what town is that way. Huh?
Yeah,
The
the
lake.
lake.
Nephi? Is Nephi that way?
Yeah, we'll
Maybe
say.
some of it.
Yeah.
The Pacific Ocean. If you go far enough, you'll get to the Pacific Ocean that direction.
New Mexico.
Yeah.
Baja.
No.
Las Vegas.
That's east.
Is Las Vegas. Anyway,
New Mexico
so,
is east.
most important thing, we are not starting from the
I
positive
think in
x-axis.
Arizona.
Huh?
Yeah.
Arizona, maybe.
It's like right
Anyway, and guess what? We rotate the other way. So if I was drawing 216 degrees, I would start here and I'd go that way. Guess what? Totally different. We are changing our paradigm. We've got a heading. We've got navigation. We are rotating clockwise from north. All right. Sorry, it was more than 60
So
seconds.
heading rotates clockwise and bearing rotates counterclockwise.
Bearing rotates
whatever
toward
the
that.
west.
So if we
Okay.
had something like south 60 degrees
Then it would
east,
rotate clockwise.
so from the south, toward. So from here, we're going to rotate toward the east, 60 degrees, we'd be going that, or we'd be looking at something, you know, that way, which is like, you know,